Hello my dear champions, welcome back to our channel Deeksha Karnataka. I hope you are all doing wonderful, you are all doing great. Yes, and so today I have brought the king of all, the integration chapter, which is highest weightage of your entire KCET syllabus as well as your PU2 syllabus. Okay, your board syllabus. Boards has 18 marks, KCET has 6 to 7 marks. Sometimes minimum of 6 will be asked in KCET from this particular chapter. And yes, 1 or 2 might be very difficult also, but others will be very simple and you can score at least 4 to 5 marks from here as well. How can you do that? By simply following this class till the end, watch and learn all the concepts, and of course I'm going to solve a lot of questions also. So we'll solve those questions, learn the concepts, and later we'll have a live. In that I'll take more questions on integration and solve each and one of them for all of you. Okay, so today very clear, integration high weightage chapter, 18 marks in your PU2, and KCET has 6 marks weightage. We'll learn all the concept, we'll solve the questions, and then later I'll come up with a live. In that I'll solve more questions of this chapter. Make sense? Yes sir. So if you're ready to start, let me know in the comment section. Let us start now, sir. I understand this session is recorded in nature, but I do follow your, when this session is streamed to all of you, when it's premiered to all of you, I can see your comments, your chats that is going on. That's yes sir, this part is very good. I am getting to understand this for the first time. All of those lovely comments makes my day. That's why we are all here, right? Your every love that you guys give in the form of your likes, your subscription of this particular channel, everything which is given to all of you is for free. So everything that you do that to give back to us actually gives us more energy to come back and deliver better and better classes to help you more and more. Okay, and there are many things planned. The time is not yet come for boards, but we have planned a lot of things for all of you to help you to get out score in your boards and in your KCET, especially in maths, because this is an easy chapter, right? Easy subject actually altogether. So that's why we can score very high in this, and we will together. Okay, subscribe to the channel right now. Keep the notification bell always on so that don't miss any of the classes. They are very important. A class missed is a marks lost. That's how it works right now in the very high, risk and reward time of your sessions. Okay, let us start, sir. What is there first thing? So I started the very basic. The formulas which is important in this chapter to understand is going to be listed over here. I've written all of them down. So for a constant, we know the formula K will be integrated as Kx, x power n is what? X power n plus 1 by n plus 1. So you can look at the formulas for all the different functions. These are the formulas. The 6 ratios are given over here. Trigonometric ratios are given over here. Sine Ax. I've written here Ax. I hope you understand that. Sine Ax is written. What it means is basically if you have a constant multiplier to the variable, you have to divide by that constant in the result. Okay, check here. What is the constant over here? The constant over here, this A value over here is 1. So divide by 1 actually. Okay, so actually you always divide by the constant, but in these cases where the x is multiplied with the constant 1, we don't write it, we don't have to show it, right? That's why it's not written over here. But usually whenever you have sine 2x, what is the integration of sine 2x? Minus cos 2x by 2. Okay, so here are the 6 ratios listed over here as integration. Moving forward, we have few more in ITFs. You can see some basics integration formulas. I know it looks silly, but MCQs can come from here. Okay, 2-marker question can come from here. The combination of one of these alongside your problem of substitution method can be a 2-marker question. You want to lose that? You don't. That's why it is very important to know all these 15 very basic formulas of integration. Make sense? Moving forward, with all of you, I must ask whether you have enrolled in ABHYAS or not. Are you still thinking about it? Then do one thing. If you want to think, no, it's okay. Take this 4 free mock tests and then you think. Okay, at least solve these 4 mock tests in the next 1 or 2 days. Okay, and you can solve, you get 1 for physics, chemistry, math and biology. So do that. Take this 4 mock tests for free, then you enroll in the course. You get total of 35 paid, all at a price of 1499. Yes, and alongside that you also get this particular for free. How come free, sir? Because if you remember, if you ask your seniors, last year we did not have that, but we had the same price. We did not increase the price of the course, but we added something extra for all of you. This here, you all know the importance of PYQs, right? I know you must have solved it 100 times, but does not matter. You have to, if you are getting opportunity to solve PYQs as a test, That's a very good option. That's a very plus point. Many students have enrolled into ABHYAS because of this factor, that they are able to solve real-time PYQs test. Okay, it is a real-time exam pattern test. Okay, the timer is there. It's an online exam. I hope you all know that it's an online mock test, so you all can do it right now. Okay, take the 4 free mock test of PCMB, and then in next couple of days, at least next couple of days, take this and start solving more mock papers to increase the accuracy and speed. Okay, because KCET require 2 things, accuracy and speed, and that you can get using what? The mock test only, right? All right, sir. So I hope this is clear. Next, let me continue with the class right now. Some standard integration of trigonometric function, some unique ones. With the help of log we write. Integration of tan is what? Log secant. Integration of cot is what? Log sine. If you want to check, simply differentiate the right hand side, you'll get the result. Okay. Integration of secant will be what? Log secant plus tan. Integration of cosec will be log cosec x minus cot x. We also have a PYQ that has been on this particular formula that actually uses the other form of it. Write like this: 1 upon sine for cosec. Sir, what are you doing right now? You might ask me, sir, what are you doing right now? I'm telling you, there is a PYQ that came on the second form of this particular formula. I want to show you that formula. Okay, so you're gonna go ahead and write like this. It becomes what? Sin x. It becomes 1 minus cos x plus c. And this was what? 1 minus cos x is what? 2 sine square x by 2. And sin x is what? 2 sine x by 2 cos x by 2. The half angle formulas, yeah, 2 and 2 cancel, sine cancels. What is the result? Check. The result is log of 1 sine by cos, means tan x by 2 plus c. Yes, this question has been there and has been asked, so we'll see that. Yeah, they don't ask you to prove this, of course, but this application has been there in the question. I've taken the problem today. I'll show it to all of you. So this cosec x integration is either log of cosec minus cot or log of tan x by 2. Okay, plus c because of the constant of integration in case of indefinite integrals. Now, some properties of indefinite integral are there, very simple ones, nothing difficult. If you integrate the derivative, you get the function itself. If you have integration for a sum or difference, you can individually take the integration and then add them later. If you have a constant multiplied, you can take the constant outside like this k and then integrate the function. Next, if you have f and g are 2 functions such that derivative of fx, derivative of integral of fx is equal to derivative of integral of gx, there will be equivalent function. The integration will be equivalent in nature. Next, first question. The first few questions are taken on basics formula that we have learned. We have seen in the first few slides. We're gonna solve some questions on that. Let's start. Integration of 2 tan x minus 3 cot x. Very simple question. Expansion you're gonna do. Square is there, so right here. 4 tan square x. Forget about integration right now. Let's do the expansion. 4 tan square x, 9 cot square x, and minus 6 into 2, minus 12 into tan x cot x, that is 1. Right? 2 into 3 is 6, into 2 is going to be, the formula is what? 2ab. 2 into 2 into 3, that's going to be 12. Multiply tan and cot, that's 1. They are reciprocal to each other. 4 tan square is nothing but 4 secant square x minus 1. 9 cosecant square x minus 1 again, and we have minus 12. Simplify and write it together. 4 secant square x plus 9 cosecant square x. We have minus 4 minus 9 is minus 13 minus 12. That's minus 25. That's minus 25, right? Correct? No, minus 4 minus 9 is minus 13. Minus 12 is minus 25. Integrate now. Once you get this result, integrate now. It's simple. 4 tan x here plus 9, sorry, my bad, minus 9 cot x over here minus 25x and plus c because of indefinite integral. That's your answer. Why minus? Because integration of cosec square is minus cot x, not plus cot x. Integration of secant square is tan x, but not for cosecant square. It is minus cot, not positive of cot. Moving on. First question is clear. Next, e power x log a, e power x is there. Looks difficult. It's a very simple question actually. Take e and log are reciprocal of each other. e power, I can write this as log a power x, because this x will come over here. That's what was written in the question. So e power log is there. They are what? They are inverse of each other. Can negate the effect, we'll have only a power x left. What is the next one? E power x left, dx, integrate. Same power, different bases. Right here, ae power x dx. A is a constant, e is also a constant. A and e is a constant. So if I take ae as one constant, it becomes what? Something to the power x dx. This is exponential form. Remember, integration of a function a power x dx is what? A power x ln a. Okay, same way, this will become ae power x and ln whatever it was there, the base ln ae plus c. Yeah, so ln and log is same thing. Here you go. That is it. That is it. ae power x ln ae plus c. Option B is correct, beta. Option B is the right choice. Moving on, next one. Yes, the antiderivative of this means integration of this. Again, simple question. Separate the term over the two signs that we have, plus 2 by 5 x plus 3 by 5 power x. Integrate them. Same result is there, right? We have 2 by 5 power x log or ln of 2 by 5 plus 3 by 5 power x ln of 3 by 5. ln of 3 by 5. Answer is option C. Answer is option C. Next, so I think it is making sense now, the kind of question that can be expected on, of course, in the very basics ones in the PU2 side will be something like that. But yeah, in KCET, the questions are a little bit difficult, but not very difficult. Only one question or two question maximum will be very challenging. Other than that, other 4 questions will be very easy. We can solve it with our learnings. Yeah, this one. 1 plus 2 sin x by cos square x. Separate the terms over the plus sign. 1 by cos square is secant square x. 2 by sin x, and we have cos square. So I get 2 by sin by cos as tan, and 1 by cos is there, so secant x. I know few of you must have skipped what I'm trying to say over here. Check here. 2 sin by cos. I'm taking one of the sin with cos. It becomes tan. We still have one cos left. It is cos square. So it becomes 1 by cos as secant. Integrate now. Integration of secant square is what? Tan x. This will be what? 2 secant x plus c. Answer is option C. Clear? Let's move on. Yes. Next is sin 2x minus 4 e power 3x. Now this is the one I was asking about, when you have a constant multiplied to the variable x. Integrate this part, you'll get what? Sin integration is, sir, minus cos. So minus cos 2x as it is, divided by the value 2. This is clear, sir? Yes, clear, sir. Next, minus 4 is a constant, keep it outside. Integrate e power 3x, remains e power 3x, but divide by 3. So what is my answer? Minus cos 2x by 2 and minus 4 by 3. That is option C. So when you have a constant multiplied to the variable, you got to divide it by that after integration in the result. Next, simple question which has combination of e power log x and then polynomial function and also a constant. Just take x with the power of a, take a with the power of x, and take a power of a. This will transform. Check here. E power log of a power x plus e power log of x power a plus e power log of a power a. E and log are inverse of each other. It means we'll negate the effect. Simply I'll have a power x, x power a, and a power a. That's my integration. A power x is what? A power x upon ln a. X power a is x power a plus 1 upon a plus 1. This is what? A power a x plus c. Here you go. Okay, I think option is going to be yes. Oh, this is wrong, right? This is log x. It should be log a actually. Check here. Difference is there. So option is A. If anybody is thinking, sir, you are writing ln, they are writing log. They are the same. In your syllabus, they are taking log actually as ln only. They say log, but they mean ln, because log actually has different something. If I write here log, let's say A, okay, log of A. In this syllabus of yours, it means with the base E only, and log with the base E is written as simply ln. So log A or ln A is same in your syllabus, but usually when you write log, you have to write a different value for base, either 10, which is a common log, or different something other base, which is other than E or 10. Okay, clear? Moving on. Next is a simple question, same concept. Integration of sec square is what? Tan 7 minus 4x. We have minus 4 here, means divide by minus 4 plus c. Okay, tan 7 minus 4x, that is what we have. Yeah, option A is correct. Check. Coefficient of x will be divided. Done. Next we are moving to the, so basics are clear, basics how to deal with the functions, different type of combinations in the integral formulas. Now we're gonna move on to what? Your method of integration. Okay, method of integration. In this, the most important and the most subtle one is going to be this one. Highly rated is your method of substitution. Not because the question directly comes like that, but it has application in over almost all the questions. Whether you talk about definite integral, whether you talk about concepts in continuity and differentiability, anywhere you will find the application of substitution. Very helpful, very easy. Without it, question becomes very difficult. Okay, even we have solved questions on this, remember, using ITF also. And when it comes to substitution, we have maximum 3 categories in substitution. We have logarithmic, we have trigonometric, or ITF based. Maximum we move around this only. Logarithmic, trigonometric are the more, like trigonometric and inverse trigonometric, log and exponential. So they are the inverse of each other, but basically logarithmic substitution or substitution for your trigonometric functions will be the ones we're gonna keep using it maximum number of times. We also have sometimes some cases of polynomial. We'll show that to you. Don't worry, I'll show you all the list. Okay. Next method is your method using partial fractions. One question comes over here. Remember, x upon x plus 1. That type of question comes in your CET as well as in your boards, and by parts, so one question is guaranteed in both the examination. Okay, great, sir. So MOI is clear. Method of integrations we can understand now. Moving on to the first one, which is substitution. Now, of course, we know that we have to substitute something. Then the next question comes to us is what to substitute. The question is what to substitute. So whichever functions derivative you can find in the function, for whichever function derivative you can look like, then some term is there in the given integration. Listen to me. In the given integration, they have some term given which looks like derivative of some function. That becomes your substitution actually. So see here, can you see this? This looks like derivative of the function given over here. It means the function becomes what? Phi x is my substitution. Phi x is my substitution, and if you differentiate, you're going to get what? Phi dash of x dx equals to dt. What is this? Differentiating this whole thing with t, this becomes 1, moving t on dt on that side. If you want to know this with dt, and d of t with t will become 1. This side will be 1 actually. So we move it over here, and this becomes what? dt. And what is this going to be? Phi dash of x dx. You can see that it's present over here. It becomes f of t dt directly. This question is what? F of t dt. So initially, before substitution, the question looks difficult, challenging, not possible to solve also. But once you substitute it properly, you get the result very easily, and you can apply, you can know which type of formula will be used in that particular question. Okay, sir, this is clear. So, sir, the question is answered. You look for those functions whose derivative are present in the given integration. Those functions becomes our respective substitutions. Okay, sir, makes sense. Same here. Ax plus b will be my substitution over here, because derivative of this is what? Derivative of this will be what? A, simply. A is a constant, we don't have to worry about that. It will become simply 1 by a dt. Over here, phi x, so phi dash is there. We have fx, we have f dash of x, we have, what is this? fx and we have f dash of x. These are going to be my substitutions present in the given function. It can be in the quotient form, product form, function of function form, and so on. Great. Next, some standard substitutions, that is in the case of, check here, trigonometric substitutions are here listed. If you have this kind of root present, you can take x as a sine theta or a cos theta depending upon what is the requirement. Yes, and this becomes, what is this going to become? Check here, a square minus a square sine square theta. If you take this, becomes what beta? Check here, you can take a square common, 1 minus sine square theta, the root. This will be what? A square cos square theta, the root. Question becomes a cos theta. Now, is it easy to integrate or this one? Tell me. Which one is easy to integrate? Of course this one, right? Means wherever it is used, I'm not saying it is going to be always used as integration over here, but wherever it is used, whenever you see this form, try to take x as a sine theta or a cos theta. Next, if you have a square plus x square, take x as a tan theta or a cot theta. Likewise, I have listed all the given different forms in the substitution. You have to go ahead, check it out. How can you do that? By downloading the class notes in PDF. Okay, now I want to tell you all one more thing. I do feel like at times that you need a proper, apart from the Masterstroke, the ABHYAS is there, good, you're doing ABHYAS test series, but apart from all of that beta, I think you also need a structured, proper learning schedule. You need timely practice, timely mock test, because on YouTube sometimes you, of course, you are working very hard over here to watch the classes and you follow everything, download the notes, revise it, but I feel that the exam is very nearby, whether it is KCET, right, or PU2. You need something very structured, and if you need that, let me know in the comment section. Even if it is going to be very difficult for us, we'll try to help you in that. If you need a structured planning, a structured sessions, if you need something like a mock, regular mocks, all of this you need, let us know this requirement that is there, sir. We need to do it for our KCET in the comment section. Our team will work on it, will look at it, what we can do about it. But I do personally feel that this might not be enough, okay, because what happens, you are children's, okay, you can get easily distracted. It's difficult to follow up all the time, and it's online. I cannot come to your home and say, did you study this class, did you watch this session? You keep messing it up, you keep missing the classes, and you have too many backlogs. Can you solve all those backlogs right now if you don't follow the structured planning? So I feel that you need the structured learnings. Okay, so for that we'll see something we can do about it, but only if you need it. If you don't need it, it's okay then. But if you need something structured from our side, let us know in the comment section of this video. Okay, I think this part is clear, right? This part makes sense, no? Special substitutions of trigonometric functions. Now a question on that. Cot upon ln sin x, we can see that clearly, sir. This makes sense. Ln sin x is the function, take it as t. Differentiate now. I'll get 1 by sine for log. Sine derivative will be what? Cos x dx dt. Cos by sine. Cot x dx dt. Cot x dx. Integration becomes dt by t. This part is taken as t. 1 by t integration. ln t plus c, sir. T is what? T is, sir, ln of ln sin x plus c. That's how simple it is. That's how simple it is. Okay, sin 2x upon sin square x plus 2 cos square x. How do you solve it? Another very simple question. You'll see, I can make here 1 plus cos square, and that is something like that is there in the options also. Let's try to do that. How come? If I have sin square x plus cos square x plus cos square x over here, and here we have sin 2x, combine them, check here, sin 2x, this becomes 1 plus cos square x dx. Differentiate this part, differentiate, you get 2 cos x minus sin x dx as dt. What is this going to be? This is going to be, sir, 2 sin x cos x, so minus sin 2x dx as dt. It means, check here, I do have sin 2x dx. It means this whole thing becomes minus dt upon t. So I get the answer as minus ln t plus c. Minus ln is what? 1 plus cos square x plus c. Minus ln cos square x plus 1 plus c. Where is it? Option is C. Check here. Option is C. This is the type of substitution we can hope for, we look for in the examination. Here it is, 1 minus tan upon 1 plus tan. A very simple question. Don't you do one thing? Do one thing. This is your, let me call this as homework number 1. Homework number 1. Give me the answer in comment section. It's a very simple question. I would like to know the answer from all of you. Homework number 1. 1 minus tan upon 1 plus 1 minus tan upon 1 plus tan. Integration is there. Again using substitution method. Let me know the answer. Okay. Answer A, B, C, D is there. Let me know answer for homework number 1 is what in the comment section right now. Let's see how much of you are actually learning, just coming and watching few minutes and going. No, that's not allowed. You have to watch till the end, learn all the questions. This one. This is a very simple one. Ln x will be what? T. So this becomes 1 by x dx as dt. We have 1 by x dx. This becomes what? Dt. So this question is nothing but t power n dt. Answer will be t power n plus 1 by n plus 1 plus c. What is t? Ln of x power n plus 1 by n plus 1 plus c. Okay. Answer looks like option A. Answer looks like option A. Makes sense? Yes, sir. Okay, moving on. Next. E power x 1 plus ex sine of x e power x. How do you solve it? This is the question I'm talking about. This was a PYQ. Very simple question. Take this x e power x as t. Differentiate. You have to apply here what? Product rule. It becomes 1 into e power x plus x into e power x dx is dt. Check here. Take e power x common, you get 1 plus x dx as dt, and you have that in the numerator. You have that in the numerator. This whole thing becomes dt upon 1 by sine. So 1 by sine t dt. That is cosec t dt. Now we know the integration of cosec is what? Integration of cosec is log of cosec minus cot. But we also have integration of this as integration as a log of tan t by 2 plus c. Do we have the t value? Of course we, sir. Tan of x ex by 2 plus c. Tan of x ex by 2 plus c. As I mentioned, the same formula is used in one of the question, and it is written over here. B is the right answer. B is the right answer. Not difficult at all, right? Are the questions feeling difficult to you? They are not, right? Don't worry. When I come back in the live and solve the PYQs, again you will feel that they are very easy, sir, and it makes sense. Whatever we are learning over here are very relevant, and we are going to use them to solve questions in our integration chapter in KCET and both PU2. Now, some formulas are there for particular functions. This here is a log formula, both of these. When the no roots are present, it is what? Log of x minus a by log of x minus a by log of x plus a. Yeah, same log will come, of course. Log of x minus a upon x plus a, 1 by 2a will be there. Here also it becomes a minus x. When you have, it comes in denominator. A plus x by a minus x, 1 by 2a. That also is there. Sometimes this question comes in your boards to prove also. In that, what you're gonna do? Simply, if this is coming as a proof, because this series Masterstroke we have included the PU2 part also this time, so that you can revise at the same time the concepts. So proof when you're doing, no, go about this question like this: x minus a, x plus a. And then you convert this into a partial fraction, a upon x minus a and b upon x minus x plus a, and then solve the coefficient. You'll get the same answer, 1 by 2a, x minus a, x plus a. Making sense? This also the same approach. Same approach, it will be a minus x and a plus x. You can do it? Yes. This one, Substitution, if this proof comes, substitute for the proof. X as A tan theta. A tan theta. X as A tan theta will be your substitution if you want to prove it. Formulas are listed over here. For proving, this is the result. Okay. For the first one, this is the one. For third one, this is the one. For second one, similar approach, of course. A minus x and A plus x. Next. Few more are there, important ones. If you have x square minus a square, we have again the concept of log over here. Log of x plus, same thing repeats. If you have same thing with the plus sign, everything is same, just here we have x square minus a square, here we have x square plus a square. In these two results, nothing changes, just here the root changes. Whatever the root is there, you're going to write the same root. If you have a square minus x square, then this becomes a sine inverse question. Okay, this is same as sine inverse. I'll repeat. If x square is negative, it becomes sine inverse, but if it is positive with minus sign or plus sign, it comes as a log question. Log of x plus, the same root repeats. Log of x plus, the same root repeats. Very simple pattern to remember the question. If you have x square positive in the root, then the same root will repeat with log of x plus. Log of x plus, same root will repeat. If x square is negative, it becomes sine inverse of x by a. Here also same thing. X square is negative, sine inverse result. Positive, there is no sine inverse. Both are with log. X plus this, x plus the same root repeats. This also is same. Check here. X by 2, the same root. X by 2, the same root. A square by 2 is constant. Plus and plus continues. Yeah. Some more types of particular function. This is from NCERT. This is where, because as I mentioned, this is going to be a class which is going to be relevant for your PU2 also, the NCERT part. So whenever you have this form, 1 upon quadratic, whether in simple form, fraction, or with the root. Okay. Then what you're going to do? Simply try to convert this into perfect square. Convert it into perfect square. Okay. Once you convert into a perfect square, how are you going to do that? Start with this. If you have x square, you'll have either plus or minus, but means you have 2 or x also. And then see what is the missing part, and then you will look for the square. That's the formula. X square, 2xy, and then y square. That's the formula of x plus y or x minus y. Don't worry, we'll see some questions on it. No problem. If you have this case, when you have linear by algebra, linear by quadratic, then what you're going to do? Differentiate this and put it equal to px plus q with a. Numerator is what? Px plus q equals to a times of derivative of ax square plus bx plus c and plus b. Compare them to find the value of a and b, and then later use this instead of px plus q and solve it. Okay, that's the result. I hope you got it. Differentiate this, multiply with a plus b, compare that with px plus q, write the value of a and b, use this part instead of this in the integration. I'll show you. Let's start. Okay, same question, let's try. Same thing what we're going to do right here. 7x plus 3, and this is equals to a times of derivative of this derivative will be what? 2 minus 2x. 3 will be 0. For this you will get 2. For this you get minus 2x plus b as it is. Check one more time. Same thing is there. A times of derivative of denominator plus b. Same thing we have. Now compare. Simplify this. We get here minus 2ax, and we get here plus b and 2a. I've written the constant together and the variable term together. Compare, we have 7x plus 3, it means we have the value of minus 2a equals to 7. It means a value is minus 7 by 2. Minus 7 by 2. If a value is minus 7 by 2 means from here compare the constant term. We get 3 equals to b plus 2a. It means 3 equals to b times of 2 times of minus 7 by 2. 2 and 2 cancels. So I get 3 equals to b minus 7. It means what? B value is 10, sir. B value is 10, sir, actually. B value is 10. Got it? A value is this and B value is that. Now check. As I said, remove that part 7x plus 3 and write this instead. So a is what? Minus 7 by 2, and we have 2 minus 2x, and the b part is plus 10. So plus 10, and this whole thing by the same thing, this root divided by this root. Correct, no? Because we have numerator, replace 7x by 3 by this whole thing. I did that. B is 10 and writing the same root. This root can be written in this form. Please check one more time. 3 plus 2x minus x square is there. 3 plus 2x minus x square is there, no? So write this as, take 3 over here, minus sign common. You get x square positive and minus 2x you get. X square positive minus 2x you get. Now take add plus 1 and remove minus 1. Why is that? Because you're getting a formula. X square minus 2x plus 1 becomes a x minus 1 the whole square. This minus 1 comes out, it becomes plus 1. This actually, this root is becoming what? Check here, this root is becoming what? 4 minus x minus 1 the whole square. 4 minus x minus 1 the whole square. Correct or not? Please check. Yes or no? Yes, sir. Because this becomes x minus 1 the whole square. This will be minus 1, comes out as plus 1. Plus 1 becomes 3 plus 1 is 4. Okay. So you can see here, this is forming 10 by 2 square x minus 1 the whole square. This is very simple. This will become what? 10 times of sine inverse of x minus 1 by 2. Check. Sine inverse of x minus 1 by 2. We have two options as such. We have two options as such. And one of the option has plus 7 in it. Other has minus 7 in it. Check the other one that we have minus 7 in it. It means clearly the option is D. Option is D. So this part, but if you want me to solve, I can solve it this part also. Check here. Minus 7 by 2 is there. 2 minus 2x we have. And write it like this. Don't write this form, write that particular form. 3 plus 2x minus x square. Of course, we have dx and we have integration. Check, bacha. Check here. This, if I take as t, what is this one? That's nothing but dt actually. If I take this as d, means 2 minus 2x dx is dt. How come, sir? We all know very well 3 is going to be 0, 2. We just got this value 2 minus 2x by doing what? Differentiation of denominator only. So this whole thing will become dt. So this actually equation becomes minus 7 by 2 integration of, what is this? Check here. dt upon t power 1 by 2. If you integrate this, you'll get the answer as minus 7 t power 1 by 2. If you integrate this, you're going to get what? Minus 7 t power 1 by 2 in the numerator actually. Hence that what we have, minus 7 t power 1 by 2 basically in the root t. What is this? Minus 7 root t plus c. Put back the value over here. 3 plus 2x minus x square. 3 plus 2x minus x square. If you want to continue to this part or get the result after getting this value very clearly, option D matches with the minus sign of 7. That is this one. Yes or no? Your choice of doing it. This is a very important question. Okay, have a look. It's a PYQ, I think. Question number, answer is option D. Clear? All of this is visible. Moving on. Next. Secant x tan x 9 minus x, 16 tan square x. This is a simple question. Expand this tan square. Why, sir? Because we have secant x tan x in the numerator. Okay, sir. Right here. Secant x tan x dx we have 9 minus 16 secant square x and plus 16, right? Correct, no? Plus 16, because if you write tan square as secant square x minus 1, it becomes 16 secant square and mass becomes plus. Okay, sir. This becomes 25. So we have here secant x tan x. What do we have? 25 minus 16 secant square x dx. Take 16 common, you get 1 by 16 over here, and we have secant x tan x. Steps are important in this question. 25 by 16 minus secant square x dx. Okay, correct? And now you can use here secant x as t. Derivative will be secant x tan x dx will be dt. This whole thing will be dt. So answer becomes 1 by 16 dt upon 5 by 4 the whole square minus t square. 1 by 16 is outside as it is. What formula is this? 1 upon a square minus x square. A square minus x square. What is that going to be? Check here. ln of, check this formula I'm talking about. A minus x, it will be in denominator. This one. ln of, check here. ln of a minus x means 5 by 4 minus t and 5 by 4 plus t. And of course plus c we have. I forgot to write 1 by 2a is there. No, 2 times of 5 by 4. 2 times of 5 by 4. 1 by 2a is also there. So 2 times of 5 by 4. Check here. So we get here 4. This is cancelled by 2 times. 2 will cancel this by 8 times. 8 and 5 is left. So 1 by 40. We have ln 5 plus 4t by 4 divided by 5 minus 4t by 4 plus c. 4 and 4 is cancelled. Put back the value of t as secant. You get the answer as 1 by 40 ln 5 plus 4 secant x 5 minus 4 secant x plus c. That's your answer. 5 plus 4 secant x and 5 minus 4 secant x plus c. Good question. You liked it? Let me know in the comment section. How was this particular problem? Yeah? Good? If I call it, let's say, homework number 2, please try again to solve without help. Okay, this is a good question. That's why I'm asking you to has the concept of substitution. Then you have to use the particular function also. So try one more time. Okay, we have 2 set of substitutions, so just try once. Sorry, only one. Okay, not 2. Only 1 is there, but yeah, please try once. Good question. Okay, try once. Homework number 2. Try again. Now, this is a simple question. This is the base, same thing that we learned. If you have a quadratic form in the denominator, make the perfect square. How do you do it? Right here. First term is x square, then write 2ab term. So write 2. Automatically we have the x is x. Okay. Now what will you write over here to get 8x? Of course 4. It means your b is 4. P is 4. You get here. Add 4 square, remove 4 square, and the constant 20 comes as it is. This is making the whole square. Check. It makes x plus 4 the whole square, and we have minus 16 plus 20. That is nothing but plus 4. Plus 4. Now we write this. Integration of dx upon, what is this? X plus 4 the whole square plus 4 means 2 square. This is the formula. 1 by a, so 2 tan inverse of x by a, so x plus 4 by a plus c. That's simple, sir. That's simple, sir. Answer is 1 by 2 tan inverse of x plus 4 by 2. Yeah. B. That's B. Done. Clear? Moving on. Next. Integration by partial fractions. Integration by partial fractions. Over here, we always integrate by partial fraction using proper partial fractions. Check here. So if you have the degree of numerator, if it is my numerator fx less than degree of the denominator, then we call this to be proper rational functions. So we apply our rules for these ones only. Okay. If you have improper, means if you have degree of fx more than degree of gx, then what are you going to do? You have to do the division actually. You have to divide first, get the quotient separately as a polynomial. This will be a polynomial. Okay, and this will be, this particular value will become your partial fraction or proper rational. Proper rational. Okay. Okay, this you're gonna take as your integration. So polynomial plus proper rational function will be taken as your partial fractions. We have some rules. Yes, we have many, but we stick to the top two. Usually the top two, top three are the ones that is appearing all the time in our examination. When you have two factors, one linear in the numerator, when we have quadratic with three factors or cubic in the denominator, and when we have simply whole squares, whole cubes in the denominator, we have the type of partial fraction, means how we take the constant a, b, c, like that you can see. Okay, so have a look. Download the PDF, go through it and apply this in the different type of questions. But usually in our syllabus, we deal with the first four types. Okay, great. Moving on. This question. This is a homework number 3. Of course, I'll help you, but this is homework number 3. X plus 1 upon x plus 2, x plus 3, a upon x plus 2, and b upon x plus 3. Cross multiply and find the fraction sum. X plus 3, b upon x plus 2, same denominator that we have. Repeat it on this side also. It means you can ignore the denominator and just compare the numerator. Ignore the denominator and compare the numerator. So ignore the denominator over here. This all you can ignore and just compare the numerator by putting two cases, x as minus 3 and x as minus 2. You'll get the value of b over here and get the value of a over here. Okay, find these two values for b and a, and use back in the integration one more time using the logarithmic function. Got it? Do this as homework number 3. Now integration by part. The most interesting, sometimes the most challenging questions usually arises from here only. When you have multiple by parts involved, then the question becomes lengthy, not difficult but lengthy, and in the time that we have, challenging to solve. Okay, great. So what happens over here? There's a rule, of course there is a rule, we follow that. But what is going to be happening over here? Based upon the islet condition. Islet means inverse, log, algebraic, trigonometric and exponential. We choose the preference order. Preference is like this: first to I, then to L, then to A, then to T, then to E. You go down, preference actually decreases. This is your highest preference order. Least to maximum. This is your max, this is your minimum. That's your preference order. Done. Islet is clear. Now with this known, if you have two functions, function 1 and function 2. What does 1 and 2 mean? Means function 1 has the preference over the function 2. Function 1 has the preference over the function 2. How come, sir? Based upon this. Then you keep the function 1 as it is, integrate the function 2 with dx, comes with a minus sign, integrate the derivative of function 1, and then integrate the second function that you got already, this value from here, take their product, and then integrate one last time. I'll repeat. Separate the function f1 as coefficient, integrate second function, derivative of first function, taking the product with this integral result, and combine them as product, take integration one more time with the same variable dx. That's your result of integration by parts. Okay, have a look. Fx, gx, dx is there. You kept fx outside, integrate gx, same result is there. Derivative of fx, integration of gx, combine and take one more time, integral. Preference is islet. Got it? Yeah? Moving on. First question, x sine 3x. So sir, islet is there. I-L-A-T-E. Algebra has a preference over trigonometric function, means this becomes my 1, this becomes my function number 2. 1 and 2. Clear? What is the result? Keep 1 as it is, integrate the second one. Okay, with dx of course, put a minus sign. Integrate derivative of the first, integrate this one, sine 3x dx, one more time, dx. That's my application of by parts in this particular question. X as it is, sine 3x integration will be what? Minus cos 3x by 3 over here. it'll become what? 1. Derivative of x is 1. And this will be what? Minus cos 3x by 3 dx. This part is dealt with. Okay, great. Now take minus sign outside, it will become plus. So you get here minus x cos 3x by 3. Minus minus becomes plus. Integration of cos will be what? This time sin 3x by 3, and we already had a 3. So 3 into 3, we get the answer as minus x cos 3x by 3 plus sin 3x by 9, and plus constant c of integration will be of course present. Got it? Simple question on the application of by parts. Moving on, definite integral. Okay, so we are looking to now, so first part of indefinite is over now. I have covered all the concepts, but now in the definite, the limits are involved. So two things are very important. In definite, the technique to go through the question of substitution changes. Whenever you apply substitution in integration in definite integral, you have to change the limits. So let's learn about limits right now. Let's say integration of a function fx dx is actually coming as gx plus c. Gx plus c. But when the limit is defined from a to b, then this changes. Let's say it is a to b. So you're going to define this function at b. You'll end up with what? G of b plus c. This is the upper limit. This value is called as upper limit, minus g of a plus c. This value is called as lower limit. Check here. You get gb plus c minus ga minus c. C cancels. You have the answer as gb minus ga minus ga. This is the result for integration of a function with the variable x under the limits a to b if the integration in the indefinite form was gx plus c, gb minus ga. Done? Makes sense? Very simple? Of course it is very simple. This question, let's try to understand this. We get here 3, this is x power 3, this is x to the power 1 by 2. So x power 3 minus 1 by 2, same here, minus 4 x power 2 minus 1 by 2 plus 1 x power 0 minus 1 by 2, because 1 means x power 0. Okay, now simplify this. You get 3 minus 1 by 2 means 3 minus, so 5 by 2, x power 5 by 2. Here we have 4 power 3 by 2, correct? No? And we have simply x power minus 1 by 2 with a plus sign. Integration is there for each of these. Let's worry about integration first, then we'll use the limits. Of course we have to write it down. Right here, 3 outside, it will become x power 5 by 2 plus 1, 7 by 2 divided by the same value, 7 by 2. Here also 4 into x power 5 by 2, because if you add 3 by 2 plus 1, it will become 5 by 2. Again 5 by 2. Here also we have x power 1 by 2 by 1 by 2. Now write the limits value 0 to 1. Check here. This is coming as 6 by 7 x power 7 by 2. Here this is coming as 8, 4 to the 8 by 5 x power 5 by 2. This is going to be plus 2 x power 1 by 2. Simplified so far. Now put the values of x as 1 and 0. For the upper limit, this is my upper limit beta, this is my lower limit. Okay, put x value as 1, it becomes 6 by 7 into 1 is, I can ignore that, minus 8 by 5, and here we have plus 2, because when you put x as 1, any power will make it 1 only, right? And for lower limit, 0, because x, if you put 0, everything will be 0 only, sir. Simplify. What we have to simplify now? 6 by 7 we have, minus 8 by 5 and plus 2 we have. LCM will be 35. 7 5s are, so 6 5s is 30. 5 7s are means 8 7s will be 56 and 70. Okay, this is going to be minus 26 plus 70 by 35. Difference you take now. 25 it was means 45, so 44 actually by 35. This should be your answer. Please cross check and let me know in the comment section whether it is the same or not. 44 by 35 or not. Have a look. Now next, 0 to pi by 4, 1 minus sine 2x integration we are looking for. This is a, what is this? It's a perfect square actually. How come, sir? Check here. Cos square x plus sine square x minus 2 sine x and cos x. This is the value of 1, these two things, and this is the value of sine 2x. So it becomes cos x minus sine x the whole square, sir, in the root. It becomes plus cos x minus sine x, where the modulus of cos is there. Integrate this value from where to where? 0 to pi by 4 dx. 0 to pi by 4 dx. Check the graph of cos x and sin x. Sine is like this, cos is like this. This value is pi by 4. Cos x is at pi by 4 is always equal to sin x, but before pi by 4 will be always higher. Cos is in the interval 0 to pi by 4. Okay, open if I take, cos of x is more than sin of x always. Cos x graph is higher. It means difference will be what? Positive. Positive. If you have a positive number and you have a modulus, it has no meaning. Okay, so simply you can take this as 0 to pi by 4 cos x minus sin x and integrate this result. Integrate this result. Integration of cos x is what? Sin x will become minus cos, so plus cos x from where to where? 0 to 1. 0 to 1. Put sine of, sorry, 0 to pi by 4, my bad. Pi by 4. Put pi by 4. So sine 1 by root 2, cos also 1 by root 2. This is your upper limit. Lower limit to check, sine 0 is 0, cos 0 is 1. This will become what? 2 by root 2. That's simply root 2 minus 1. That's my answer. This value is my answer. Root 2 minus 1 is my result. Please have a look. Yes, clear? Let's move on then. Now, evaluation of definite integral by substitution method. As I mentioned, whenever you're using this particular technique, you got to be very careful. Just don't forget to change the limits. Usually we make the same mistake. So if you are changing a function, let's say gx as t, means g dash of x dx becomes dt. Good, sir, this part will be dt, but you have to change the limit of a and b as well. Limit of a and b as well. Okay. Yes. So basically this will become what? Check here. We'll get here g of a to g of b f of t dt. This is how you change the limit also. When x equals to a, t is g of a. When x equals to b, t is g of b. So you have to change the limit also. Do not forget that. Next, it should be the same thing written over here. If you are using the method of substitution, you have to change the limits. Got it? You have to change the limits. Okay, moving on, sir. Let me raise these markings. The questions wise we'll check. Tan cube x and sec square x is there. Clearly we can see tan and sec are the functions and derivative. Tan x is my substitution. It means secant square x dx is dt. One thing is clear. This part is dt. Good. Clear. No problem. What about the limits change? When x is 0, the lower limit you check now. This is my lower limit. When x is 0, what happens to tan x? T will become tan of 0. So again 0. When x is pi by 4, t is what? Tan of pi by 4, which is nothing but 1. Now you check. Integration from where to where? 0 to 1, because this is my upper limit. Lower limit is what? 0, upper limit is 1. So 0 to 1 will become t cube dt. Integrate now. T power 4 by 4. We write plus c over here? Not anymore, because it is a definite integral. 0 to 1, put 1, get 1 by 4 minus 0. Answer is 1 by 4. Option is A. Option is A. Simple. Next. This is a simple question. Just the change of limits we want to show you once. Now this question again same you can see over here. Yeah, this makes sense. 1 plus e power x is there. This is going to be my function t. Derivative is there or not? Yes, it is. Have a look. Differentiate 1 will be 0. Differentiate e power x, dx and dt. Check numerator. Same thing is there. Yeah, it means that this is correct. But limits. Lower limit you check now. When x was what? 0. We'll have 1 plus e power 0 as t. It means t becomes 1 plus 1. So 2. T is 2 for the lower limit. What about upper limit? Same thing. When x was what? Log 2. Then this becomes what? T becomes 1 plus e power log 2. We know e and log are inverse functions. Cancel the effect. Hence answer will be 1 plus 2. Answer is 3. Answer is 3. Now integration changes. 2 to 3. This is simply dt upon t, right? Upon t, dt upon t, correct. The answer will be ln t. From where to where? 2 to 3. It means ln 3 minus ln 2, upper limit minus lower limit. Difference means we can use the quotient rule. ln 3 by 2. ln 3 by 2 or log 3 by 2. Option is C. Application of substitution in the definite integral by change of limits. Clearly is mentioned how you're going to change your lower and upper limit. So no chances or no room for mistakes, beta. You cannot do that, okay? It's already been clearly explained to you. Just learn over here and apply in the questions. Next, some properties of definite integral. So we know that some of them are asked in examination. Yeah, so we have King's rule that has been asked, right? We ask in the exam, they ask us regularly. These two rules, proof is asked in your PU2. I have taught you these proofs many times in my marathons, in my preparatory preparations, wherever it came, I have taught you this many times. Okay, again I'll teach you. What you're gonna do is simply there's a series of results that we use in this proof. I'm going to give it to you. I think I have given it to you in one of the sure shot questions also. So go ahead and check it out. Okay. These are the two properties that comes all the time. Let's look at all of them one by one. Limit a to a means same limit is there. Derivative will be, integral will be 0. Because if you get g of a minus g of a, it's simply 0. It will be coming as g of a minus g of a. Remember, if it was a to b, we had gb minus ga. In this we have ga minus ga. How much is that? 0. A to b fx dx is nothing but, if you have a to b and you want to write b to a, just introduce a minus sign, it will become minus b to a. This we use in the proof of the other integration over here. In both of them actually, we use this property. Okay. In the same function, we can change the variable. Limit is same, ab, function also same, just the variable x dx changes to t dt. This also is used a lot. So both these properties are extensively used to prove the last two properties, 6 and 7. Property number 4, a to b fx dx is nothing but a to c fx dx plus c to b fx, means we can keep breaking down the limits n number of time depending upon the situation. Just make sure that your first limit, lower limit is same as the question, and the last limit's upper limit is same as the question. Got it? I remove the marking to have no confusion so far. Next, if you have 0 to 2a, I can break it down as 0 to a fx dx plus 0 to a f of 2a minus x dx. Property 6 and 7, I already explained it to you. For even and odd functions, for even it remains twice of 0 to a fx, and for odd it remains 0, right? Because f of minus x becomes what? Minus f of x. And this for even function. Proof also I have given. This one, property number 7, this is the King's rule. When you add the limits, when you substitute x as sum of the limits minus x. Okay, got it? Moving on. Let's solve a question on it and then conclude our session. Okay, so now it's time to close our session with one question on the property of definite integrals. Okay, sir. Let me take this as integration I, and this is my equation number 1. What I'm going to do, change this x by sum of the limit 1 plus 2, 3 minus x. Sum of the limit minus x. Do that. Will the limit change, sir? Of course not. I remains as it is. Limit will be 1 to 2. We have this as 3 minus x. X is replaced by 3 minus x. Here we have 3 minus x, first one. X replaced by 3 minus x dx. As I mentioned, integration does not changes, limit does not changes, nothing changes. Check here, this is the same integration. Limit also remains same, just you replace x by sum of limits minus x. Okay, simplify this. We get this as 1 to 2 root 3 minus x upon, this will be 3 and 3 cancelled. You'll have plus x over here. You'll have root 3 minus x dx. Check, this is my equation number 2. Can I add this equation number 2? Can I add this equation number 2? I can. Why? They have the same limits and same base. 1 to 2, 1 to 2 and same denominator. Check here, root x plus root 3 minus x. Root x plus root 3 minus x. We can do that. It means I plus I will become 2i. Check here, limit will be 1 to 2. Denominator, root of 3 minus x plus root of x dx, and numerator over there root x, and over here root 3 minus x. Root 3 minus x. Check now. This is same thing, means we can cancel them out. Yeah. So what do we have left now? We have only 2i in the left hand side, and over here we have 1 to 2 only dx left. Okay, integrate this. We'll get x from where to where? 1 to 2. I'm getting this value as 2i equals to difference of 2 and 1. So 2i equals to actually 1. It means I equals to 1 by 2. 1 by 2. This is my answer actually. This is my answer actually. If this question is coming to prove it like this, you have to show in the whole steps. But if it is an MCQ, if this type of question comes in MCQ and you are able to identify the pattern, then simply use this trick as upper limit minus lower limit by 2. Check, upper limit is 2, 2 minus lower limit is 1, divide by 2. Answer is what? 1 by 2, and that is same as this result. If the question comes in MCQ, use the direct result, upper limit by lower limit by 2. That's your answer. Got it? This concludes our session, our class in Masterstroke of integration. I've tried to give everything that you need from this chapter. If I missed something, let me know in the comment section. And of course, I would like to see your comments once the session is already published on the channel, and would like to see what was your answers, what was your improvement in this class, and keep working hard. You will certainly do better every class by class, but do not miss any of the classes better, because very, very useful right now. If you miss a class, you'll have backlogs, you won't have time, and you lose marks. Okay, so class missed is equivalent to marks lost in KCET in PU2. It's very important. The last stretch is left. We have to be very serious right now. Okay, our whole team is working really hard to give all of this required, inquiries. Whatever you asked, we are delivering it right now. So you should be very sincere and take the maximum out of these classes. Okay, so keep working hard, keep smiling. I'll see you in the next class. Till then, take care. Bye bye.